Hello students, we are starting solving quadratic equation by factorization. You have studied this type of examples in 9th standard and 8th standard. Factorization means splitting the middle term. The another name is splitting the middle term. Now, two equations are given here. One is x square minus 15x plus 54 and another is x square plus x minus 20. This is, this is called first term, this is called second term, middle term, this is called third term. First term, middle term, third term. Similarly, first term, second term, third term, we can call middle term also. What to do now? Splitting this term. This 54 can be written like 17 into 2. 17 to the 34. 18th reason. 54. 18th reason 54. But the sum of 18 plus 3 is 21. So these numbers are not useful. We should find such numbers that the product must be the last term, third term, and the sum must be the middle term. This is called splitting the middle term. So remember, 27 twos is also 54. But 27 plus 2 is equal to 29. These are also not useful. So, if you have got mastery over the tables, you will get immediate the numbers which are, when multiplied, we get 54 plus 54 and the sum must be minus 15. And those numbers are minus 9 into minus 6 is equal to plus 54 and minus 9 plus minus 6 is equal to minus 15. So these type of examples are called splitting the middle term. We have got 18 3s are 54, but 18 plus 3 21, not useful. 27 2s are again 54, but 27 plus 2 is equal to 29, again not useful. But minus 9 into minus 6 is plus 54 and minus 9 plus minus 6 is equal to minus 15. These two numbers are useful. So this you might have studied in 9th standard also. This is called splitting the middle term. So I am erasing this. So the final numbers are minus 9 and minus 6. Therefore, x square minus 9x minus 6x plus 54 is equal to 0. Now taking out the commons, x into bracket x minus 9 minus 6 into bracket x minus 9 is equal to 0. Again these two are common, take them out, and the remaining is x minus 6 is equal to 0. In 9th standard, we were making the brackets and we were getting the answer. But here in 10th standard, we have to equate them with 0. Means x minus 9 is equal to 0 or x minus 6 is equal to 0. So x is equal to 9 and x is equal to 6. Therefore, roots are 9 and 6. So remember, splitting the middle term means you have to get such numbers whose sum must be the coefficient of middle term. Sum must be the coefficient of middle term and product must be the last term. Sum must be middle term and product must be last term. Understood? If you have got any doubt, then you have to refer 9th standard teacher. Yeah, this is 10th standard. We are moving very fast in 10th. So this is revision of 9th standard. So 9th standard things you must be clear before 10, reaching to 10. This one. So minus 20. We got minus 5 into, plus 5 into 4 is equal to minus 4. Plus 5 into minus 4, minus 20. Plus 5 plus minus 4 is equal to plus 1. So, using these numbers, we'll get x square plus 5x minus 4x minus 20 is equal to 0. Taking out the commons, x into bracket x plus 5 minus 4 into bracket x plus 5 is equal to 0. So x plus 5 and remaining is x minus 4 is equal to 0. Therefore, x plus 5 is equal to 0 or x minus 4 is equal to 0. So x is equal to minus 5 and x is equal to plus 4. So roots are minus 5 and 4. This is the answer. Now we are starting little bit different type of examples. Same, but one step will be different. See, in previous examples, the coefficient of first term was 1. The coefficient of first term was 1. Now, it has got some different number. This means there should be some different method we have to adopt. First you have to check the coefficient is different. It is not 1. It is not 1. If it is 1, splitting the middle term. If it is not 1, then first term into last term. Coefficient of first term. Coefficient of first term into last term. So it is 2 into 13 is equal to 26. Here it will be 5 into 15 is equal to 75. So this is first term into last term. First term into last term. Now you have to split this 26 in such a way that you will get the sum of those numbers is middle term. So 26 ones are 26 and 26 plus 1 is equal to 27. These numbers are useful. So 2y square plus 26y plus 1y plus 13 is equal to 0. So this method is called first term into last term. So taking out the common, y into bracket or 2y into bracket y plus 13 plus 1 into bracket y plus 13 is equal to 0. So y plus 13 and the remaining is 2y plus 1 is equal to 0. Then y plus 13 is equal to 0 or 2y plus 1 is equal to 0. Therefore, y is equal to minus 13 and y is equal to minus 1 upon 2. So roots are minus 13 and minus 1 upon 2. So once again I am repeating. The first term is not having coefficient 1. So the coefficient of first term into last term, it gives us 26. Split that 26 in such a way that the product must be the number which is got from multiplying the numbers and the sum must be the middle term. So it is 26 ones. After putting these two things between these numbers, it is also splitting the term, but we are splitting the number by getting first term coefficient into last term. Clear? And this one now. This is fourth example. This is therefore 5m square minus 22m minus 15 is equal to 0. So 5 into minus 15 is equal to minus 75. We should get the sum minus 22. So minus 25 into 3 is equal to minus 75 and minus 25 plus 3 is equal to minus 22. Using these numbers, 5m square minus 25m plus 3m minus 15 is equal to 0. So taking out the common, 5m into bracket m minus 5 plus 3 into bracket m minus 5 is equal to 0. Therefore, m minus 5 and remaining is 5m plus 3 is equal to 0. So, m minus 5 is equal to 0. M minus 5 is equal to 0 or 5m plus 3 is equal to 0. Therefore, m is equal to 5 and 5m is equal to minus 3. Therefore, m is equal to minus 3 upon 5. So the roots are 5 and minus 3 upon 5. So these type of examples where the first term's coefficient is not 1, these type of examples are called splitting the middle term. With first step, multiplying first term into last term, and then splitting that number in such a way that the sum must be the middle term. See, 27 plus 1, 27, 26 plus 1, 27, and minus 22, minus 25 plus 3 is equal to minus 22. 26 plus 1, 27, and minus 25 plus 3 is equal to minus 22. These type of examples are called first term into last term, coefficient of first term into last term, and the previous one were simple splitting the middle term. Clear? So let us solve fifth example of exercise 2.2. Check the first term. It has got coefficient other than 1. So this must be first term into last term. So 2 into half is equal to 1. 2 into half is equal to 1. And the product of minus 1 into minus 1 is equal to 1. So this will be 2x square minus x plus half is equal to 0. Plus half is equal to 0. This is fifth example of your textbook. Fifth example of textbook, page number 36. Correct. So by putting this, we will get, take out the commons. So x into bracket 2x minus 1 and 1 and half is smaller, so half into bracket x minus 1, 2x minus 1 is equal to 0. You can check if you are having the old book. I have marked star on this example, because you will make a mistake of taking 2 here. So 2 means you will take 2 outside. So it is x into bracket 2x minus 1. And this is, you can check, 2 2s are 1. Minus 1 is there. Minus outside half, inside it is 2x plus 1. So these two are common. Therefore 2x minus 1 and remaining is x minus half is equal to 0. So 2x minus 1 is equal to 0, or x minus half is equal to 0. Therefore 2x is equal to 1 and x is equal to half. So x is equal to 1 upon 2. You can check, the roots are same, half and half. In the answer, the back side of the exercise, they might have given the answers. You can check, roots are half, comma, half. This is not in the standard form, so we have to make first standard form. So multiplying by x multiply by x. 6x into x minus x into 2 upon x is equal to 1 into x is equal to no. Therefore, 6x square minus 2 is equal to x. Therefore, 6x square minus x minus 2 is equal to 0. This is the standard form of your exercise number 2.2, sixth example. We are solving sixth example. So, it is first term into last term. So, 6 into minus 2 is equal to minus 12. 6 into minus 2 is equal to minus 12. If you understood these things, then definitely you will understand all the factorizations. So, minus should be there. So, minus 4 into 3 is equal to minus 12 and minus 4 plus 3 is equal to minus 1. Taking these numbers, we will get x square, 6x square minus 4x plus 3x minus 2 is equal to 0. Otherwise, 3 this side and 4 that side. Taking out the common, 3x into bracket x plus 1 minus 2 into bracket x plus 1. Taking out common is a little bit tedious job, but you will practice, then you will get the things done. Therefore, x plus 1 and 3x minus 2 is equal to 0. So, x plus 1 is equal to 0 and 3x minus 2 is equal to 0. So, x is equal to minus 1 and x is equal 3x is equal to 2, and lastly x is equal to 2 upon 3 and x is equal to minus 1. This is exercise number 2.2's sixth example, and the final answer is 2 upon 3 and one second. We will do this one again. I have taken different constant with it. So, putting these numbers, 6x square minus 3x minus plus 3x minus 4x minus 2 is equal to 0. Correct? If you take these two numbers, they have taken like this, plus 3x minus 4x minus 2 is equal to 0. So, 3x into bracket 2x plus 1 minus 2 into bracket 2x plus 1 is equal to 0. Sorry for the confusion. I had taken one number differently. So, it will be 2x plus 1 and 3x minus 2 is equal to 0. Take equating with zeros, 2x plus 1 is equal to 0 and 3x minus 2 is equal to 0. So, 2x is equal to minus 1, 3x is equal to 2, x is equal to minus 1 upon 2 and x is equal to 2 upon 3. So, the final roots are minus 1 upon 2 and 2 upon 3. These are the correct answers. I had taken the constant differently. So the final answer is 2 upon 3 and minus 1 upon 2. These examples are very good examples of splitting the middle term and first term into last term. 6 examples I have made, solved in front of you. Next, we are in 7th example of exercise 2.2. What is the speciality of this example? The example contains root sign coefficients. So some students may get confused when they see root signs. But it's very easy, don't get afraid and don't get scared. See, first you have to check the coefficient of first term. It is not 1. So it is first term into last term. First term into last term. First term into last term. So coefficient of first term is root 2 into last term 5 root 2. Into last term 5 root 2. So root 2 into root 2. Root 2 into root 2 into 5. 5 into root 2 into root 2 is equal to 5 into 2. So it is becoming 2. 5 into 2, 10. It is 10. So we need two numbers in such a manner that their product must be 10 and sum must be 7. Product must be 10 and sum must be 7. We got the numbers 5 into 2, 10 and 5 plus 2, 7. We got the numbers. By practice you will get quickly these numbers. We have got the numbers, we are putting them. See, root 2x square remaining same. 5x plus 2x from factors. We got m and 5 root 2. So the equation is root 2x square plus 5x plus 2x plus 5 root 2. This can be written like this. Root 2x square same, 5x same, but 2 can be written as a root 2 into root 2. For convenience of factorization, we are making 2 as a root 2 into root 2. Now I have marked the common things. X square and x will be common. From this x square and x will be common. Root 2 and root 2x and 5 are in the bracket. Got it? So out of these x is common. Why I have made this root 2 into root 2? This root 2 and this root 2 will come out as a common. So root 2 has taken common, and remaining root 2x plus 5 is in the bracket. So let us see. These two brackets are common. Therefore, root 2x plus 5, the remaining is x plus root 2 is equal to 0. Therefore, either root 2x plus 5 is equal to 0 or x plus root 2 is equal to 0. Therefore, root 2x is equal to minus 5 or x is equal to minus root 2. Then x is equal to minus 5 upon root 2 and x is equal to minus root 2. Actually, your book has given minus 5 upon root 2 as answer, but you have studied surds in 9th standard. In the denominator, root signs are not allowed. If you rationalize, the answer will be different. If you rationalize this denominator, the answer will be different. But for textbook, I am keeping the answer as it is. So roots are minus 5 upon root 2 and minus root 2. Once again I am repeating. This answer is, I have kept this answer for textbook purpose. They have given like this. But as per mathematics, the root sign should not be in the denominator, and we have to rationalize it. If your teacher is going to rationalize it, then definitely the answer will be different and it should be something else. So this is 7th example. 8th example is also having root signs. Let us see 8th one. We are in the 8th example of exercise 2.2. One more example with root signs. 3x square minus 2 root 6x plus 2. 3x square minus 2 root 6x plus 2. Check the first term. It has got coefficient other than 1. It has got coefficient other than 1. So first term coefficient into last term. 3 into 2 is 6. First term into last term. So 6 can be split in like this. Minus root 6 into minus root 6. Minus root 6 into minus root 6 is equal to 6. If your teacher has taught you surds in last year, surd part, then definitely you will know this. Root 6 into root 6, root into root gayab, number bahar. So this is the rule. Minus root 6 into minus root 6 is equal to 6, and minus root 6 plus minus root 6. Minus root 6 plus minus root 6 is equal to minus 2 root 6. Minus root 6 plus minus root 6 is equal to minus 2 root 6. Using this number, we have solved this one. Put these things. So 3x square minus root 6x minus root 6x plus 2 is equal to 0. Then for convenience of taking out commons, you may not understand the things properly, so I have split again. Root 3 can be written as root 3 into root 3, x into x. So this becomes 3x square. This root 6 can be written as root 3 into root 2, root 3 into root 2, root 6, last year's third part. Again, this root 6 is written as root 3 into root 2, root 3 into root 2, and this 2 is written as a root 2 into root 2. Refer last year's third part, you will get the things clear. It's very nicely written. 3 means root 3 into root 3. Root 6 means root 3 into root 2. Root 6 means root 3 into 2. And 2 means root 2 into root 2. Take out the common. Root 3x is common. and inside the bracket it is root 3x minus root 2. Root 3x into bracket, root 3x into bracket, root 3x minus root 2. Similarly, take out root 2 common, take out root 2 common, you will get root 3x minus root 2. Under root 3x minus under root 2, under root 3x minus under root 2 are common. We have taken these two common. The remaining is root 3x minus root 2. Root 3x minus root 2. So is equal to 0. So again equating these two with zeros, root 3x minus root 2 is equal to 0, and this root 3x minus root 2 is equal to 0. So root 3x is equal to root 2. It has passed to that side. Similarly, this minus root 2 went to that side, it becomes plus. So final is x is equal to root 2 upon root 3. Root 2 upon root 3. And here also root 3 upon root 3. Root 2 upon root 3. So the roots are this. Root 2 upon root 3 and root 2 upon root 3. Roots are same. Why they are same, we will come across in the alpha and beta part of this lesson. So this was 8th example of this exercise 2.2. So let us start 9th example of the same exercise 2.2. Open up these brackets. So 2m square minus 48m is equal to 50. Just open the brackets. Therefore 2m square minus 48m is bring that 50 to this side, it is minus 50 is equal to 0. We brought that 50 to left hand side. Sign change. To make the number small, divide by 2. So m square minus 24m minus 25 is equal to 0. And this is simply splitting the middle term. So minus 25 is equal to minus 25 into 1, and minus 24 is equal to minus 25 plus 1. Sum must be the middle term and product must be the last term. Sum must be the middle term and product must be the last term. Therefore, m square minus m plus m, say, and minus 24m minus 25 is equal to 0. When you take such numbers in a given way or in another way, you will get confusion here. What should be the common? So while taking the middle terms, we must be very careful. M square and 25. The numbers are 25 and 1. 25 should be last and 1 must be at the middle term. So it will be minus 25m minus 25. In short, choose the numbers where you can take out the commons easily. You can take the common numbers easily. So from these two and these two, m into bracket m plus 1 minus 25 into bracket m plus 1 is equal to 0. So it will be m plus 1 and m minus 25 is equal to 0. Finally, m plus 1 is equal to 0 or m minus 25 is equal to 0. Therefore, m is equal to minus 1 or m is equal to 25. So roots are minus 1 and 25 respectively. This is simple splitting the middle term. Choosing the numbers are very important. While taking out the commons, you must feel easy. 25 you can take out common. 1 you can take out common. So this is the way we can solve this example. This is 9th example of exercise 2.2. This is 10th example of exercise 2.2. See what they have done. Middle term they have taken out. 25m square is equal to 9. 25m square is equal to 9. When you transfer that 9 to left hand side, it will become 25m square minus 9. 25m square minus 9. This can be rearranged or rewritten like 25 is a square of 5. M square is a square of m. 25 is a square of 5 and m square is a square of m. So we have taken down and made it like 5m the whole square minus 9 means 3 square. This is nothing but the identity a square minus b square. This is nothing but the identity a square minus b square. So what is a square minus b square? When we expand it, a square minus b square is equal to a plus b and a minus b. So what is our a? 5m. What is our b? 3. So a plus b means 5m plus 3 and a minus b means 5m minus 3. Our a is 5m, our b is 3. So when we expand this type of identities, we got 5m plus 3, 5m minus 3 is equal to 0. And then equating with zeros, this 5m plus 3 is equal to 0 or this 5m minus 3 is equal to 0. Transfer the number, plus 3 becomes minus 3, minus 3 becomes plus 3. 5m is equal to minus 3, 5m is equal to 3. And then dividing by 5, we got m is equal to minus 3 upon 5 and m is equal to 3 upon 5. So roots are minus 3 by 5 or 3 by 5. Very simple. But no splitting, no first term into last term, nothing. Just identity we have applied of 8th standard identity we have applied. 8th standard identity gave us the answer. This one now. This is 7m square is equal to 21m. This is 11th example. Yeah, last but one example of 2.2. Yeah. So this is, we transfer this 21m to this side. Therefore, 7m into bracket m minus 3 is equal to 0. 7m common. 7m into bracket m minus 3 is equal to 0. This is 11th example. These type of examples they have put in the last of the exercise purposely to make you surprised. This is taken out common 7m. So therefore either 7m is equal to 0 or m minus 3 is equal to 0. Product is 0 means one first term is 7m and second term is my m minus 3. Either of them is 0. So 7m is equal to 0 or m minus 3 is equal to 0. Therefore, m is equal to 0 upon 7 and m is equal to 3. So, that 7 will give us 0 when we multiply that 7 with 0. Means 0 upon 7 is nothing but 0 and m is equal to 3. Therefore, roots are 0, 3. 0, 3. This is depending on the 8th standard identity and this is depending on taking out the common. Both are surprising examples. No splitting, no first term into last term, nothing doing. They are just taking out the common and 8th standard identity. Very nice things. So this is last example of exercise 2.2. They have given us m square minus 11 is equal to 0. This is a quadratic equation. Middle term is missing. Let it be. This can be written as m square minus root 11 the whole square is equal to 0. M square minus root 11 the whole square. Root 11 square is 11. Root 11 square is 11. So this is nothing but again the identity a square minus b square is equal to a plus b and a minus b. Therefore, applying these things, our a is m plus root 11, our b is root 11, and second is m minus root 11 is equal to 0. Our a is m, our b is root 11. So, a plus b, a minus b. Equating with zeros, m plus root 11 is equal to 0 and m minus root 11 is equal to 0. Therefore, m is equal to minus root 11 and m is equal to root 11. So, the roots of the given equation are root minus root 11 and root 11. Last three examples are very simple one. Identities and taking out the common. This finishes our factorization method. Factorization method is for final exam, at least there will be 2 examples of these types. It's very easy, and then we are starting, in next lecture we are starting solving the quadratic equations with squaring, perfect squaring method. It's very nicely I will explain, and you will understand within just 2 or 3 examples. So, thank you. Best of luck.